Hey guys, in this video the lovely Mr. B is going to be going over lots of examples to do with radians for your A-level maths. Now there are lots of examples here at 3 different levels, and you can skip through using the timestamps down below to where you feel most comfortable. To go with this, there is an online course and the workbook which is available for immediate download. So much stuff, so many questions to really help you prepare for your exams.
Radians are an alternate way to divide up circles. Now, the way we're used to is degrees. With degrees, a circle is split up into 360 degrees. Now, the problem with this is that 360 is a number that's been chosen by people to use. And it's been chosen because it has lots of factors. So you can divide 360 lots and lots of different ways. You can divide it by almost every number. You can divide it by 1, 2, 3, 4. You can divide it by 5 and 6. You can't divide it by 7. But you can divide it by 8 and 9 and 10. If you're trying to divide something up, you want to be able to divide it in lots of different ways, have lots of options. That's what 360 gives us. But again, it's been made up by people. So with radians, what we do is we divide a circle up into 2 pi. Now, the reason for this is that mathematicians wanted something that wasn't just kind of invented by people. They wanted something that had some kind of mathematical meaning. And so with pi being the number of diameters that fit around the circumference of a circle, 2 pi seemed like a good number to use. And what this also does is some circle equations become much easier when you use radians instead of degrees. You can kind of simplify bits away and get answers far quicker. Now, what we need to be able to do is to convert between degrees and radians. Now, this is something that typically can be a little bit confusing, but as long as you remember that degrees are 360 and radians are 2 pi, you're going to be able to make the conversion. Now, converting degrees into radians, which we need to do for this question, all you need to do is look at the 2 numbers. Look at the numbers first. We have 360 and we need to get to 2. So how do you get from 360 to 2? Well, you divide by 180. Now, 360 doesn't have any, but 2 pi has a pi symbol. So we need to add in the pi symbol, so we multiply by pi. You can do a similar process the other way around, converting from radians to degrees. So again, look at the numbers first. We're starting with 2, and we need to get to 360. So how do you get from 2 to 360? You need to multiply by 180. Then we look at the symbols. Radians got a pi symbol and degrees doesn't. So to get rid of it, we need to divide by pi. Because you divide a number by itself, you get 1, you multiply by 1. We're not going to have any change. So now we can have a look at a question. We have 221 degrees. We want to convert it into 2 decimal places, radians. So looking at my little chart here, from degrees to radians, I need to divide by 180 and I need to times by pi. And so you simply just need to put that into your calculator. 221 divided by 180 multiplied by pi is going to give us 3.86 radians to 2 decimal places. And we use a little to show that's in radians rather than degrees. So let's look at some other examples. So for this question, we're converting 3.53 radians into degrees. So from radians to degrees, again, have a look at the chart. We're going to multiply by 180 and we're going to divide by pi. And again, it's a simple matter of putting that into your calculator. 3.53 multiplied by 180 and then divided by pi. That gives us an answer of 202, and to 2 decimal places, it'll be 0.25 degrees. The next question is an example of why working with radians can be helpful. So we have 1/6 pi radians. And this sort of notation is common for radians. So rather than having, a number that's maybe been rounded, we can write an exact value for it. Now we want to convert it into degrees. So to do that, from radians to degrees, we need to multiply by 180 and we need to divide by pi. Now what we can do here is the fraction multiplied by 180 would give us 180 over 6. So I'm looking at the numbers first. Then I'm going to look at the symbols. I've got a pi and a divide by pi. Now, pi divided by pi, number divided by itself is going to give you 1. If you multiply by 1, it's going to stay the same. So you can see straight away, I've got something here, and I can simplify this as well. I can do 18 divided by 6 is 3, and we have the 0. So the answer is 30 degrees. And so I got the answer without needing to use a calculator. And this is the kind of simplification you can find when you put radians into other equations, such as circle equations and things like that. you can find things that are going to simplify. Or you can leave your answer with a pi symbol so you don't need to round. And so we can do the same thing in the other direction. So we're going to convert 120 degrees into radians. And to go from degrees to radians, we're going to divide by 180 and multiply by pi. So what we can do is we can write the divide as a fraction, 120 over 180. When we multiply by pi, we can actually leave pi in the answer so we don't get that irrational number that inevitably we need to round to write on the page. All we need to do now is to simplify the fraction. And it looks like 60 can go into both of those, which is going to give us 2/3 pi. So we have an exact answer with something that's an irrational number. So again, this is another benefit of using radians. So looking at another example like that, we have 30 degrees. I want to turn it into radians. So we're going to divide by 180 and multiply by pi. So first off, we can write our division as a fraction and leave pi in as a symbol. Then we simplify the fraction. Again, this looks like 30 is going to go into this, 130 and 30, and there are 6 30s in 180. So that's going to give us 1/6 of pi as our exact answer in radians. Now, do you want to write an exact answer or a decimal? Always read the question. So some of these questions said write 2 decimal places. That's telling you it wants a value. And these ones haven't, which is telling you that you can leave them as exact answers. Question might even say write your answer in an exact form. And again, that's where you're going to leave pi in as a symbol. So now let's do some calculations using radians. So first, we're going to find the arc length. Now for arc length, that's talking about the length of the section of the circle we have. And this is a segment of the circumference. So you think, well, what's the formula for the circumference? The circumference is pi d. Now that's for the total circle. We don't have a full circle. We've got a portion of the circle. So what we do is we're going to take pi d and we only want part of it. So we're going to divide pi d by a full circle in terms of the angle. And in radians, that's going to be 2 pi. Then we're going to multiply it by the part of the circle we have, which is we've got 1/3 pi of the circle. And if we work this out, we're going to get the length of the arc. So let's start to substitute. So d, the diameter, that's going to be double the radius. So 117 times 2 is 234. And we're dividing it by 2. Now you'll be thinking, well, what about the pi? I've not written pi down. Well, look at where pi is. We've got 1 pi in the numerator and 1 pi on the denominator. So what that does is we can simplify and we can do pi divided by pi, which is 1. And if you multiply by 1, the number's not going to change. So it's effectively been cancelled out. So by working in radians, kind of one of the complicated bits, which is working with multiple pi's, a lot of them just cancel themselves out. Then we're going to multiply that by 1/3 pi. So we can just use our multiplying fraction skills here. So we're going to have 234 times 1 and 2 times 3 pi. And now we have a fraction that hopefully is going to simplify quite easily. And 234 divided by 6 actually gives us 39. So our answer is 39 pi. And you'll see a lot of this calculation could be done without a calculator. Now, what you want to think at the end is for an arc length, it's probably going to be suitable to have a value for it. So we're actually going to work out 39 pi in at the end. So 39 multiplied by pi is going to give us 122.52 to 2 decimal places. And the radius is in centimeters, then the arc length is also going to be in centimeters. Now, what is the benefit of doing it this way? Well, if we had worked this out, perhaps using degrees, perhaps using pi not as a symbol but as a value, what would happen is in every stage of this calculation, every time I wrote pi down, I'd actually have a complicated irrational decimal to write down. I'd have to round it, and that can introduce inaccuracies to the calculation. Now, I've only rounded once in this entire calculation, and that's right at the end, where I did 39 times pi. Whereas doing this with degrees, or again, not using pi as a symbol, but a value, you would be rounding throughout the calculation, and that's going to rack up more and more and more errors as you work your way through. So this is a more accurate way of doing it. So let's practice finding another arc length. Now, the formula for a full arc is going to be pi times d for a full circumference, but we only want part of the circumference. So we divide by the total of the circle, which is 2 pi radians, and we multiply by the part we actually have, which is 1/4 pi. So we can start to simplify this and substitute. So d is the diameter. Now the radius is 87, the diameter is double that. Be very careful with this. So the diameter is 174. And again, to be divided by 2. And we can safely ignore the pi's because they are going to cancel each other out. We're going to multiply by pi and divide by pi. It's not going to make a difference. We're multiplying that by a quarter pi, which is going to give us 174 multiplied by 1. And 2 times 4 is 8. Then we simplify the fraction, 174 divided by 8. We'd hope it would give us a whole number. In this case, it doesn't. It gives us 21.75. So we could write 21 and 3/4. Now, I use a calculator for that, but you could use various fraction methods for this. For example, you could simplify it by dividing through by 2 first because they're both even numbers. You could convert to a mixed number. There's methods you can use without a calculator. At the end, think about what an appropriate answer would be. And again, for like a physical length of something or an area of something, you're probably going to want a value, especially for your final answer. So 21 and 3/4 pi, if we pop that into a calculator, that's going to give us 68.33 to 2 decimal places, and the units are in centimetres. Now, our next question is somewhat of a reverse question. We're actually given an answer for the arc length. It's 279.25 centimetres. We also know the radius is 100 centimetres, so we've been asked to work backwards and find the angle. So again, let's just think about how you would do this with a full circle first. If the arc length was a full circle, then you would have pi d for the full circumference. But we don't have the full circumference. So we divide it by the full circle, which would be 2 pi, and then we multiply it by the amount of the circle we have, which at the moment we can only say is theta. We only have, an algebra kind of symbol for that because it's a missing part of the equation. But that's going to be equal to the arc length, which is 279.25 centimeters. So what we can do here now is start to substitute into it. So the radius is 100, the diameter will be double that, 200, and we're dividing that by 2. The pi's cancel out like in the previous questions, multiplying that by theta, and it's equal to 279.25. So then we can do 200 divided by 2, it's 100. So 100 theta is equal to 279.25. So what we need to do now is divide both sides by 100 to solve the equation. And so that's going to give us 2.7925 for theta. Now, this answer is in radians, so there's a few things we can do with it. So we could convert it into degrees, for example. So 2.7925, we want to divide it by pi. And divide by pi, it's quite interesting. We get 0.8 recurring, so we'll come back to that. Then we multiply by 180. And so what you find is to actually, if you round to 2 decimal places even, you're going to get 160 degrees as the angle of this. Another thing you can do is try and get it back into nice simplified form. Now we've got 2.7925. If we divide that by pi, we get the 0.8 recurring. And we've got 0.8 recurring pi radians. And we can change 0.8 recurring into a fraction. That's going to be 8/9. So we could also write it as 8/9 pi radians. But by doing that, it wasn't actually 0.8 recurring. It was 5 eighths in a row, and then a 0.357. So what this is telling me is then perhaps the arc length itself was originally rounded. And if the angle is 8/9 pi, then that arc length has lost a little bit of accuracy. And again, this is just showing the benefit when you work entirely in radians and leave answers, as fractions, leave pi in answers so you don't need to round. You get more accurate working. So we've got 4 different versions of the answer here. So you use whatever the questions asked you for or whatever seems the most appropriate. The next question also gives us the arc length. And again, we're looking for the angle. And again, the arc length is a partial circumference. So first think about what a full circumference would look like. It would be pi d. So to get part of this, we're going to divide by a full circle worth of radians, which is 2 pi, and then multiply by the radians we have, and we don't know, so we write theta. So now we can start to substitute. So the diameter is going to be double the radius, so that's going to be 246 over 2. The pi's cancel out, multiply by theta, and it's equal to the arc length we've been given, which is 257.61. So we can easily divide 246 by 2. It'll get us back to 123. So we have 123 theta is equal to 257.61. So we need to divide that by 123. That should give us a value for theta of 2.09 to 2 decimal places, and that's in radians. Now, if we divide that number by pi, it tells us a few things. The first thing, if we divide it by pi, is that we're going to have 0.6 recurring pi radians, which looks a little bit simpler perhaps, but we can write it as a fraction as well. 0.6 recurring is 6/9. So you've got a single digit recurring, it's going to be a ninth. So that's 6/9 pi radians. Now again, doing that divide by pi, it doesn't give us exactly 0.6 recurring. We've got it to about 5 decimal places. So again, that's telling us that the original arc length may have been rounded slightly, and that it actually is indeed exactly 0.6 recurring. But again, with a question like this, you need to think about what the question is asking you for. So 2.09 radians is probably going to be the final answer for most of these questions. Only continue and take pi out. It was asking you for the answer in a particular form. Also be aware that you can convert the answer into degrees. So you can divide 2.09 by pi and then multiply it by 180. And that's going to give us the 120 degrees. But again, always look at what the question is asking you for. Don't write an answer in degrees if it wants the answer in radians, and vice versa. The next question is also a reverse question where we are given the arc length, but this time we're actually also given what theta is. It's 5/6 pi. It's written in radians. What we're looking for is the radius. But again, we follow a similar process. We imagine we have a full circle. A full circle, the arc length would be pi d. If we have a partial circle, we divide by a full circle, 2 pi, and we multiply by the part of the circle we have 5/6 pi of it. So now we can substitute. Now, we don't know what the diameter is. It's going to be 2 of the radius. So perhaps we could write 2r because we're trying to find r as our final answer. So we can't do anything with the diameter. We are going to divide it by 2, and the pi's are going to cancel out. And then we're going to multiply that by 5/6 pi. That's going to be equal to the arc length, which is 196.35. Now we've got quite a nice fraction to simplify. 2 divided by 2 is 1. So we've just got r. So we do r multiplied by 5/6 pi. That's going to give us 5/6 pi multiplied by r. So now we want to get r on its own. So we're going to take the 196.35 and we are going to divide it by 5/6 of pi. Well, one thing you might want to do is actually rewrite it in that format so the examiner knows what you're trying to do. And that should give you an answer of 75. Now I'm getting 75.000, so that's pretty accurate to 75. So you're rounding to 1, 2, or even 3 decimal places, we'll get exactly 75. And so we can write 75 centimeters as our final answer. The next set of questions are focused on using radians with sector area. So the area of a sector is just the area of a segment of a circle or a sector of a circle. Now you think, well, what's the formula for the area of an entire circle? And for an entire circle, it's pi r squared. Now we don't want a full circle, we want part of a circle. So we take our pi r squared, we're going to divide it by what makes up a full circle, which in radians is 2 pi. And multiply it by the number of radians we have, which is half pi radians. And so the working out for this is very similar to what we've been doing with the previous set of questions. It's just a different equation. So we can start to substitute into the equation. So r squared, that's a radius squared, that's going to be 180 squared. We're dividing by 2. And again, the pi's are going to cancel out. But then we multiply by a half pi. So we're going to reintroduce it with the next part. Now, looking at the fractions, 80 squared multiplied by 1, that's going to give us 6,400. And then for the denominators, we've got 2 times 2, which is 4. And 6,400 can be divided by 4. That's going to give us 1,600. So we can say that the area is 1,600 pi. But again, for things like this, typically you want a value as your final answer. So we take the 1,600 pi, take 1,600, multiply it by pi, and that gives us 5,026.55 to 2 decimal places. And if the radius is in centimeters, then the area is going to be in centimeters squared. So again, same method we've been using. It's just a radius, it's a diameter, and we have to square the radius. So let's practice that method with another question. Again, we're looking at sector area. So we start off thinking about a full circle, which is pi r squared, but we want a partial circle. So we divide it by the number of radians divided up into 2 pi, and we multiply it by the number of radians we have to get the part of the circle we're looking for. We can substitute into this. So the radius squared, that's going to be 107 squared. Dividing it by 2, the pi's cancel out, and we're multiplying by 2/3 of pi. So 107 squared is 11,000 449. So we are going to multiply that by 2, and it's being divided by 2 times 3, which is 6. So let's divide that number by 6, and we get 3,816.3 recurring. So we could write 0.3 recurring, or we could write a third. That's up to you, the same value. And we have pi on the end. So again, for our final answer, take our value, 3,816.3 recurring. We are going to multiply it by pi to get a value, and that gives us 11,989.36 to 2 decimal places. The units are going to be centimeters squared. So now let's have a look at some reverse questions. So we're given the sector area. We can think, well, a full circle will be pi squared. So to find the sector area, we want only part of that. We divide by the full circle, 2 pi. We multiply by the part of the circle we have, and we've not been given it. We've only been given theta in its place. So this is what we're going to be looking for. We're looking for the angle. So let's substitute. So the radius squared, that's going to be 122 squared. We're dividing it by 2, and the pi's cancel out. We're multiplying by theta. We don't know what it is yet, but we know the final answer. The sector area is 3,896.62. So let's start to work this out. We've got 122 squared, and we're dividing it by 2. That's going to give us 7,442. Theta is equal to our 3,996.62. So then if we divide our 3,000 number by the 7,000 number, we're going to be getting what theta is equal to in radians. And that is 0.52 radians to 2 decimal places. If you want to get a more exact answer, we can try dividing that by pi. And if we divide by pi, that's going to give us 0.16 recurring pi radians. And you might recognize that number. It's actually 1/6. So we can write as our final answer 1/6 pi radians and have an exact answer. Now, again, when we have a 0.52 radians and we divide it by pi, you're not exactly getting 0.16 recurring. It's only 6 recurring to a few decimal places. So again, this is telling me that the original sector area has probably been rounded, and that we can get this exact answer, assuming the original's been rounded. With most questions, 0.52 rounded 2 decimal places is going to be an appropriate answer. As always, read through the question and make sure you're leaving your answer to an appropriate level of accuracy. If it's asked for something specific, like 2 decimal places, or an exact answer. The next question is also a reverse question focused on sector area, but this time we're trying to find a radius. As usual, think about a full circle, pi r squared for the area, and then we're going to divide it into the bit that we have. So we divide the circle by the full number of radians, and then multiply it by the number of radians we have, which is a 1/3 pi radians. So now we can start the substitution. The radius squared, we don't know what it is, we'll leave it as that. I'm dividing it by 2, and the pi's cancel out. And then we're multiplying by a 1/3 pi. That's equal to the sector area, which is 6,804.69. So let's deal with a fraction first. Multiply the numerators. R squared times 1 is r squared. And multiply the denominators. 2 times 3 is 6. And multiplying by pi. So to get our final answer, we've got a few steps here. So firstly, we can multiply both sides by 6. So we take our 4,804.69, multiply it by 6 first. That's going to give us that pi r squared is equal to 40,828.14. Notice that I just reversed the positions of the r squared and the pi because, pi r squared is a formula for the area of a circle. But when you multiply, it doesn't matter which order. Next, we divide by pi to get r squared on its own. So r squared is equal to 12,996.006. And then we need to square root that answer to get the radius. So the radius is going to be 114, and that's correct actually to 5 decimal places. So that's pretty accurate. Then the sector area is in centimeters squared, so the radius will be in centimeters. So all you do, write in the formula for a sector area, and then just undo it step by step with these reverse questions. So let's look at our last example of radians. Again, we're looking at sector area. The full area is pi r squared. So we divide it by the full amount of radians, and then multiply it by the radians we have, which is 7/8 pi. substituting. So the radius squared, again, this is a question we don't know the radius. We're dividing it by 2, the pi's cancel out, we're multiplying by 7/8 pi. This will be equal to sector area, which is 9,241.78. Now let's multiply the fraction. So r squared times 7 will be 7r squared. 2 times 8 will be 16. It's all being multiplied by pi. So now we just need to rearrange the equation, going through one step at a time. I'm going to type the 9,241.78 into my calculator, and we'll just reverse this step by step. So firstly, let's divide by pi. So we're going to get 7r squared over 16 is equal to 2,941.74994. Then multiply both sides by 16. So 7r squared is going to be equal to 47,067.99904. Then divide by 7. That will give us that r squared is equal to 6,723.999863, and then square root the answer. And that will give me that r is equal to, and I'm getting 82 as my answer, and that's going to be correct to 6 decimal places, because I'm actually getting 81.999999. The sector area is in centimeters squared, so the answer is going to be in centimeters. Now, you'll notice that when I solve this equation, I wrote each step, I wrote the full number of decimal places. I will just be keeping those figures on my calculator and just working through step by step.